Good morning all. This is Ambika, Assistant Professor, Department of Information Science and Engineering from BMS Institute of Technology and Management. Today we will be talking about key management, introduction to key management, digital certificates, public key infrastructure and identity-based encryption. So what is key management? Key management refers to the management of cryptographic keys within a crypto system. So this includes dealing with the generation of keys, exchange of keys, storage of keys, use of these keys, crypto shredding and the replacement of the keys. Now what is crypto shredding? Crypto shredding is basically deleting of the data by either deleting or overwriting over the encryption keys. This is mainly done in order to prevent mishandling or misuse of the keys. Now key management also includes cryptographic protocol design, key servers, user procedures. User procedures are also again mainly used for the usage of these keys and other relevant protocols. Now mostly the relevant protocols that we are going to study here in these modules is the Needham-Schroeder and the Kerberos. Now the security of any crypto system would depend on how securely its keys are managed. So without handling the cryptographic keys very securely, the benefits of using a strong cryptographic scheme is usually lost. Now cryptographic schemes are very rarely compromised because their design is weak. It is usually compromised because key management is handled very poorly. And usually, since public keys are in the open domain, they are most likely to be abused or mishandled. Hence, it is very necessary to establish and maintain some kind of trusted infrastructure for the management of these keys. Now, this trusted infrastructure is usually in the form of the public key infrastructure, which we will be studying next. Now, key management has some important aspects as follows. So, firstly, cryptographic keys are nothing but special pieces of confidential data, and key management refers to the secure administration of these cryptographic keys. The entire life cycle of the key management is as shown in this diagram. So firstly you have key generation. This is the first step. Key generation is usually or basically the creation of keys or the activation of a existing key. Next step would be to establish the key, or a key establishment is also known as key exchange, where the cryptographic keys are exchanged between two parties, usually the user and the sender. And this key exchange is also usually done by using the cryptographic algorithm. Now the third step would be the key storage. Now what is key storage? Key storage is usually to store the keys, and this storage should be done in a very secure manner in order to maintain the communication security. Next step would be the usage of these keys. Now keys should usually be or very frequently be changed in order to reduce the chances of attackers finding out the key. This is similar to how you would regularly change your passwords for your emails or your bank applications, etc., so that attackers cannot easily figure out the key. Next step is the archival of these keys. What is archival? It is nothing but the storing of these private keys of a certificate so that it can be recovered later and at any future time if at all it is required. The last step would be the key destruction. Key destruction, like the word says, it is to destroy the key or removal of the instance of a key from any specified location. So this is the life cycle of the key management. Next comes the two specific requirements of key management for public key cryptography. What are these specific requirements? First one is the secrecy of private keys. So throughout the entire life cycle of the keys, the secret keys must remain a secret from all parties except for the ones who are owning these keys and the ones who are authorized to use these keys. So owner, when you say, it is usually the sender, and the person authorized is usually the receiver. Now assurance of public keys. Assurance is nothing but guaranteeing of these public keys. So in public key cryptography, public keys are usually in the open domain and is seen as the public pieces of data. That is why these are known as public keys, because they are available in open domain. So by default, there is no guarantee or assurance of whether the public key is correct and with whom it is supposed to be associated, or what these keys are supposed to be used for. Hence, key management of public key focuses more explicitly on assurance or the guarantee of the purpose of the use of this public key, the purpose with whom it is supposed to be associated, and whether the public key that is being sent is correct or not. So this is now, in order for this, to have this assurance of public key, this which is a crucial requirement, it is achieved through the public key infrastructure, or also known as the PKI. Now, what is public key infrastructure? It is a key management system for supporting public key cryptography. Public key infrastructure provides, firstly, assurance or guarantee of the public key, and secondly, it identifies the public keys and how it is being distributed. So basically, what is the anatomy or the structure of the public key infrastructure? So this PKI comprises of the following varieties, different components. So first one being the public key certificate. The public key certificate is most commonly referred to as the digital certificate. Next, coming to the private key tokens. Next, we have the certification authority, also short form known as CA, registration authority, RA, and the certificate management system, which is the CMS. Now, what are these private key tokens? Private key tokens are usually, they allow for the generation and storage of public keys, and private key tokens are also used for the authentication. Now, coming to digital certificates. Now, digital certificates are similar to the ID cards, so identification cards that are issued to a person. Now, these digital certificates are not just issued to people, but they can also be issued to computers, software package, or anything else that needs to prove their identity in the digital world. Now, digital certificates are based on ITU standard X.509, which defines a standard certificate format for public key certificates and certification validation. What is ITU? ITU is the International Telecommunications Union, and this ITU coordinates standards for telecommunications and information communication technology. So, for example, if X.509 is for cybersecurity, Y.3172 is for machine learning, and H.264/MPEG-4 AVC is for video compression. So these are just basic standards that are defined for these certificates. Now, because of this standard that is given to the digital certificates are sometimes also referred to as the X.509 certificates. Now, public key pertaining to the user or client is stored in digital certificates by the certification authority. The certification authority can also sometimes be called a certifying authority or certified authority, etc. So, this certification authority stores the digital certificate along with relevant information such as client information, the expiration date of the certificate, usage of the certificate, and who is the issuer of the certificate. So now we see in this diagram what we have is, you have your client, and this client is sending his public key to the certificate authority. It is requesting for a certificate signing, or the certificate signing request is being sent to the certificate authority. So now this certifying authority, what he does is he issues the digital certificate or the X.509 certificate and sends it back to the client. So the steps are mentioned here. The CA or the certifying authority digitally signs the entire client information, and this client information, as previously stated, has all the user details, the issuer details, and the how long the digital certificate is, expiration details, etc. And this includes the digital signature in the certificate. So next, if anybody needs assurance about the public key and associated information of the client, the certifying authority carries out the signature validation process. So first, the certifying authority will validate the public key that is coming from the client. After successful validation, the CA assures that the public key is given, that the public key given in the certificate belongs to the person who is details are given in the certificate. That is, he validates the client is correct. So this is shown in this illustration. So what happens here is the CA accepts the application from the client to certify his public key. The CA, after duly verifying the identity of the client, then issues the digital certificate to that particular client. So now what are the key functions of the certifying authority? So first one is to generate the key pairs. Your key pairs are usually your public and your private key. So the certifying authority may generate a key pair independently or jointly with the client. Next process is to issue the digital certificates. Now the CA issues a certificate after the client provides his credentials to confirm his identity. So client, what he does is he provides his correct details in order to confirm his identity, which is usually in the form of the public key. So the CA then signs the certificate to prevent any modification or any changes to the details that is contained in the certificate. After that, you publish the certificates. The CA next publishes the certificates so that the users can find them. Again, please remember this is a public domain, and so it has to be, the client's certificate has to be published. So there are two ways of achieving this. One is to publish the certificates, and then the other one is to send. The client sends the certificate out to those people who think might be requiring this certificate. Next comes the verification process. So verifying of certificates, the CA makes its public key available in the public environment to assist the verification of his signature on the client's digital certificate. Last one is the revocation. Now there are times where the CA might send out the, verify and publish the certificates, but due to some breach or some compromise in the private key by the user, or maybe loses trust in the client, etc., then at such times the CA will revoke the certificate. But once the certificate is revoked by the CA, it also maintains the list of all the revoked certificates, so that at any later date also these certificates can be brought out and again can be verified. Now coming to the classes of certificates. So there are four typical classes of certificates. First is class 1. So these certificates can be easily acquired by supplying an email address. So similar to how you enter your email address and enter your password and maybe access your Gmail accounts and whatever other email accounts. Then class 2, these certificates require additional personal information to be supplied. So maybe when you're using your apps wherein you need to give in an OTP or an additional PIN or something of that sort. Then class 3, these certificates can be only purchased after checks have been made about the requester's identity. So maybe like in your banking apps wherein you need to provide your database and an additional PIN number, etc. Then the last is class 4, which is of the highest levels of trust. So these may be used by the governments and financial organizations needing very high levels of trust. So these are the different classes of certificates. Now, what is the next component, which is the registration authority? So your CA, or the certifying authority, may use a third-party registration authority to perform the necessary checks on a person or company requesting the certificate to confirm their identity. So similar to how in your banking apps you might require a third party to check if the client who is requesting the certificate is authentic or not. So the registration authority might appear to the client as a certifying authority, but the registration authority does not actually sign the certificate that is issued. So signing of certificate is done only by the certifying authority. Then comes the certificate management system. This is a management system through which certificates are published, temporarily or permanently suspended, renewed or revoked. So certificate management systems do not normally delete certificates, but because as said, it may be necessary to prove their status, or might have to be recalled at some point in time, maybe for legal reasons or any other reasons wherein verification might be required again, and so it does not entirely delete the certificate. So the CA, or your certifying authority, along with the associated registration authority, runs the entire certificate management systems, and they are able to track the responsibilities and liabilities within this certificate management system. Now coming to the hierarchy of certifying authority. Why do we need a hierarchy? Now we know that globally there are vast networks and requirements of communication, and so it is not practical to have just one trusted certifying authority which all the users will have to depend on to obtain their certificates. And secondly, availability, due to the availability of only one certifying authority, if at all the one CA that exists is compromised, or some problem happens, then this will lead to a problem with all the other certifying authorities. So we have hierarchical certification model which is used, and since it allows the public key certificates to be used in the environments where two communicating parties do not have trust relationships with the same certifying authority. Now, as shown in the diagram here, we have a root CA which is right at the top of the CA hierarchy, and the roots CA, the certifying authority certificate, is a self-signed certificate. Now, next comes the children, or rather the CAs which are directly subordinate to the root CA, which you have your CA1, CA2 and CA3. Now the certificates of these CA1, CA2, CA3 is signed by the root certificate. Next you have the sub-subordinates of the CA1, CA2 and CA3. Now for example, you have your CA4, CA5 and CA6, and these have the CA4, CA5, CA6 have their certificates signed by the parent root. You wouldn't call them the root, but the parent certifying authorities, which is CA1, CA2 and the CA3. Okay, so similarly you have the hierarchy of the certifying authorities. So now finally you come to your identity-based encryption. What is identity-based encryption? This is a type of public key encryption in which a user can generate your public key from any known unique identifier. For example, similarly like to your email address. And a trusted third party, what they do is they calculate the corresponding private key from the sent public key. So when you send your email address, when you type in your email address, it goes to the server, and the server will verify this using your private key, which is your password, and then sends it back, or authentifies that the person that is using the email ID is you. So here there is no need to distribute public keys ahead of exchanging the encrypted data. So similarly, like I mentioned, once you're logging in for your email address, you do not have to there is no need to distribute your public keys ahead, right? You just log into your email address, log into your Gmail account by providing your email address. So what the sender does is the sender can simply use this unique identifier that he has from the receiver to generate a public key and encrypt the data. The receiver then generates the corresponding private key with the help of a trusted third-party server. This trusted third-party server is known as private key generator, or in short known as the PKG. So the success of IBE depends upon the third-party server, which is your PKG, that generates the private keys. The only information that the server stores permanently is your secret master key, which is usually a random large number that is exclusive to the security domain. Then the server uses this key to create a common set of public key parameters, including the server's address, that are given to each user who installs this IBE software. Of course, you need an IBE software to run this mechanism, and the recipient's private keys are required. So when a sender creates an encrypted message, the IBE software on a system uses three parameters to generate the public key for the message: a starting value, the current week number, and the recipient's identity, which is normally the recipient's identity is normally the email address. Now because you have this current week number or the calendar reference, the public key that is generated will automatically expire. So the user who receives an IBE encrypted email message but has not used the process before he can request, upon authentication, a private key that allows him to decrypt all the emails encrypted using his email address as the public key. Now, what are the pros and cons of using this IBE? So what are the pros? First one, no certificates are required. A recipient's public key is derived from his identity. So when you're entering your email ID, you do not require any certificate. Then second, no pre-enrollment is also required. Again, you're just entering your email ID and being authenticated, so you're not pre-enrolling yourself anywhere. Thirdly, the keys will expire, so they don't need to be revoked. So, but in traditional public key system, what happens? Keys must be revoked if compromised. But here there is no necessary, no headache of reworking the key, etc. Fourth, this is IBE is less vulnerable to spam. Then next, it enables post-dating of messages for future decryption. Then lastly, it enables automatic expiration. So automatic when due to automatic expiration, message will become unreadable after a certain date. What are the cons? So this requires a centralized server. So IB's centralized approach implies that some keys must be created and held in escrow, and they are therefore at a greater risk of disclosure. Then lastly, it requires a secure channel between a sender or a recipient and the IBE server for transmitting the private key. So these are some of the disadvantages of using the IBE method. So that completes your key management. Thank you for your time.